Welcome to a new video in my home automation and Node-RED series. And today I will be reviewing a product from NETIO, and it is a network power socket. And as you can see, it looks like an extension lead. I mean, just there's one input and output. So there is a plug and the socket on one end, and in the middle we have a device that we can control over the internet, and it also measures the power consumption, voltage, the amps, the wattage. It measures consumption, also measures the frequency and the power factor of the device. I want to get something out right in the beginning of the video, because if you think that, oh, I will be reviewing yet another, Chinese product for I would say makers and for home automation people, I don't think it's going to be that. Or if you expect that, you are probably going to be disappointed, because well, first of all, this is not a Chinese product, and NETIO is a company in the Czech Republic, in Prague. So this product came from them. This is something that they develop, and they are targeting this product probably a little bit more to the professional market. I'm a little bit hesitant to say professional market because I don't really want to classify it, but there are a few things in this device which are, definitely, more towards the professional market. For example, the accuracy in the device is, like the power measurement, the voltage measurement is 1% accuracy. This is better than the normal, let's say, Sonoff or the Blitzwolf products. There has been a lot of design decisions on this product, which is more towards the industrial usage. You can see some stats on the screen as well. So the wide temperature range, the thing that it has a zero current switching. So it will switch the relay when the AC power is, transitioning on the, let me just show you this one. I can't really describe this a lot. So when it's, transitioning the AC, the AC voltage is transitioning on the 0 volt curve. So that again just ensures longevity of the device. And there are a few other things like dust ratings on this. So all this goes to the fact that, well, even though there is no price on their webpage, but I asked them, and the absolute list price is 99 euros for this product. But of course, if you contact them, you ask for a quote. If you run a project, you would need more multiple devices, then most probably it's going to be less. But again, it's definitely not the $10, Sonoff POW or the Blitzwolf products. So just keep this in mind when you watch this video. I don't want a whole, big flame on the comments about the price and everything, and then, what you as a consumer at home can afford something like this. So it's really up to you. If you think this is absolutely out of your interest or the budget, well, you're free to switch to another video. But if you want to see how a product like this looks like, then just keep watching. And even though this product is more geared towards industrial use, it still has a lot of things in it which is more DIY focused. So I'm thinking about the fact that it can support MQTT, and it also supports Modbus or the REST APIs. As it turns out, this is going to be quite a long video. So if you are only interested in certain topics, just let me summarize what I'm going to talk about. So there is going to be a short unboxing section where we are going to look at the device. Next, I will talk about the initial setup process, which is going to be fairly short. And then we go into the configuration of the device. That's going to be quite long because I talk about this new MQTT Flex setup. By the way, so I have the MQTT model, so obviously I'm going to talk about that and not the REST API or the Modbus version. And finally, we go over to the Node-RED example where I show how you can use it in Node-RED. And I'm also going to show you how I reused one of my earlier power consumption examples to work with this NETIO device. Before we move over to the website and the actual testing, I'm just going to mention that this comes in this rather big box. So it's well packed. There are some stats on the side. You also get this quick instruction manual, and also there is a NETIO pen and a chocolate bar. So that was obviously a joke. I got the NETIO pen and the chocolate bar as well, I'm guessing as a gift for this review video. Well, thanks for very much again for NETIO for sending this and also including the goodies. And there is one more thing that I didn't mention, which is probably important from spec-wise, is this unit contains a 16 amp relay. So that probably explains the fairly chunky leads. So it's 3 times 1.5 millimeter square gauge wires inside. I showed a few pictures of the website before. I'm just going to take you through two websites or two pages. One is the product page. I wouldn't say listing because you can ask for a quote here, but it's not like an online shop at the moment. So here you see that it talks about the main features. So this is the power cable, and I've ordered the MQTT version. And besides the MQTT version, as I mentioned before, there is a Modbus version and there is a REST API version. And here in the pictures you can see the different variants, which is pretty much the same. They just have a different plug type. So all the European models, so the German, Italian plugs, the UK one, and I can't see the rest. But you can scroll through the images here. And as we are going to see in this video, we are going to use it to control it either from the web application that the device actually creates. So it has its own website where you can do most of the setup and also basic controls. But the main platform that we are going to use, or I'm planning to use this device, is via Node-RED. But besides, there is a mobile app which is also coming soon. So that's probably going to be released later on, not at the moment. And by the way, I'm going to mention about a couple of features that are still under development. So this is still a product which is being continuously enhanced and new features being added. I talked a few things about the application notes, and there are a separate page where they talk about all the different application notes. So I think AN40 is definitely something which is related to this MQTT version. But as you can see, they also provide plenty of examples how you can control this device from, for example, Node-RED. And there are examples how you do it if you pick the device which uses the Modbus or the TCP communication, the REST APIs, or URL APIs, or probably MQTT as well. So there's plenty of readings and examples here that you can find, and hopefully you will find the ones which are best suited for your application. Setting up this device is really easy. You just basically follow the instructions in the booklet, and that's simple enough, so I don't want to spend too much time on it. But you power on the unit, you will see the flashing light as you can see on the video now. And that means that the device is in access point mode. So there will be a Wi-Fi network which is generated. It will have a special SSID. You connect to that network. Your browser will automatically pop up with the captive portal, which is going to be the portal of the device. And that's where you can do the basic configuration. That's basically selecting your Wi-Fi access point, providing the password. And once you have done that, your device is going to reboot and it's going to connect to your Wi-Fi network. And once that is done, you can go into the administration page. So we are going to look at the administration page now, and there are tons of features here, so that's going to take a while, especially because configuring the MQTT is not going to be as simple as you would expect in other systems, for example in a TAS motor. This is how the administration page looks like. By the way, the default credentials are admin, which I haven't changed yet. As you can see, the device is the Power Cable MQTT, so that's the MQTT version, and it has a name which is Power Cable -OC or 0C, and I think 0C is the last 2 digits of the MAC address. I haven't renamed that, so I just left it on default, and as you can see, it has one output because there are different models which is more like a power strip, which has 4 outputs, so there would be 4 things here, and I can turn it on. And you can see that it's on and the fan is on and it's drawing 26 watts. That's, almost 200 milliamp hours. That's the voltage. We also have power factor and the energy and the frequency, and also we have a date and time since the power measurement is on. So I'm going to turn it off now. So what you can already notice here, that as opposed to some of the Blitzwolf or the Sonoff devices, this can also measure power factor and it also measures the frequency. And I was also told that it's using a more sophisticated chip, so it's more precise than what they used in a cheaper Chinese model. Also, if you've noticed the LEDs, so there is a green LED, which is always the status, so whether the relay is on and off, and the yellow LED, which is lit all the time when it's connected to the Wi-Fi network. It also flashes red when there is a message being sent. We are going to talk about the messages later. So that's how you control it from the screen. And if you click on the outlet itself, then you can rename it. You can specify how long a short on is going to be, like for 2 seconds. So we can turn it on, turn it off, we can turn it momentarily, and then it automatically turns off after 2000 milliseconds. And you can also specify the power on state. So that's nice. Let's keep the M2M protocol now. Let's go to users. So here you can specify users, create new users, or change the password of the admin user. Within settings, you can change the Wi-Fi network. There is also an option to specify a manual IP address, which is actually quite nice. You can also change the host name. In the date and time, you can set the time manually, or for example, I just set an NTP pull server, so it pulls the time automatically. There is an option to update the firmware. I haven't updated, I'm just using the firmware whatever was shipped at. And in the system, we again have a few features. So for example, we have the device name, ports, restart periods. And probably the only interesting thing, you have this locate, which means that if you click here, then the yellow LED, which is lit at the moment, is going to flash. So I guess if you have multiple units, then you can tell which one you're controlling. And also you can reset the power consumption counters. That's nice. I don't remember that. Oh, probably that exists in TAS as well, but I haven't figured out what that is. And there is a nice functionality to export configuration, and load configuration as well, which again could be useful if you are using multiple devices and you want to configure them the same way. And in the logs, I just want to compare it again to TAS. You have a console. This is pretty much the same, so you can see what messages got sent out and what else is happening on the device. So that's the basic settings and the basic usage in a really quick nutshell. And now I'm going to go into the MQTT setup because it's not going to be very straightforward. I'm saying it's not going to be very straightforward because what it uses something which is called the MQTT Flex configuration. This is the first time I'm seeing something like this, so this is also completely new for me. So now we have a trade-off in terms of configurability versus ease of use. Because again, if I want to compare it to TAS, you just specify your MQTT server details, and then the way the messages are sent is pretty much fixed in the firmware. But now here you can configure everything. And it is going to be quite a long configuration file. It's a JSON file, but everything is nicely documented and there is a lot that you can do here. Maybe you are not going to use most of these features, but I think it's worth to understand how it actually works. And by the way, if you click here to the product manual, that would open up a new page with the various manuals. And in here, what I have found, actually that opens the website, but they have an application note which says AN40 about the MQTT Flex protocol. So this is what I'm using most of the time just to understand how the settings work. And that's what I'm going to explain now. So that's going to take some time. Of course, I'm going to leave my configuration file in the video description if you want to download that. So the first section is very straightforward. So it starts with a config node, and within that, the first section is the broker. So that's simple. What is the URL of your MQTT broker? What is the protocol? Well, it's MQTT. What is the port? So I'm using my local MQTT server, which is unsecure, so that's 188.3. Whether I use SSL, which is no, to type generic, and then the username and the password. That's simple. The next section, actually, there are only 2 more sections left, which is the subscribe and the publish topics. Let's start with the subscribe because that's going to be easy. So the only thing that we can control on this device, whether that device turns on or off, or the relay of the output 1, this one, turns on or off. And therefore the subscribe section only contains basically one setting. The first is the topic that the device is going to subscribe to. So this is, I just left it on default so you can play around with it. So it's NETIO / the device name. So this is power cable -03 / output /1 / action. And here you can send in a few different settings, and we are going to look at it later, but it's also described in the documentation if I can find it. But if I don't find it, then I'm just going to refer to my flow in, yeah, it's here. So the flow in Node-RED, which we are going to talk about later. So 0 for turning it off, 1 for turning it on, 2 is to turn it, so it's a short turn off, which basically restarts the device. I'm not sure why you want to use that, but there is a functionality. 3 is the short on time, so that's the 2000 millisecond, which is the default value that you configure on the output. 4 is toggle, and then 5, output state unchanged, so there's no change. Again, I'm not sure why you want to send that, but hey, the functionality is there. And you can specify the quality of service, and you also specify the target. Again, this device has one single output, so it's always going to be output /1 / action. And then the action is, well, that's basically whatever payloads you send over. So it's basically 0, 1, 2, 3, 4, 5. So that's simple. If you would have a power strip which has multiple outputs, then you would have, for whatever number of topics that you have. But this only has one. So that's the whole, that's the subscribe thing. And the other one is the publish. So what are the different values that this device can publish? Again, if you scroll down to the list here, so it has a section which says about all the different messages that it can publish. And as we can see, the values are output /x/, of course, again, in our case, it's going to be just one. So it can publish voltage, it can publish the current, the power factor, the load. So the load is actually the power. The state, so that's the state of the relay. And I mean, yeah, we have action, delay, name. I don't think that they are particularly useful in most cases. It can also action the output, the frequency, the energy start. So that's basically the Unix time when the energy monitoring started, or from what time the consumption is monitored or counted. And there is also a text version of that, so which is already text formatted. So these are the different things that the device can publish. And actually there are a few more settings, I'm going to find it at some point, where it can also publish things like what is the uptime, what is the RSSI. So those are more admin data that you might want to use for something. So let's look at the first one, which is the state. So obviously, if the state of the relay changes, we want to publish that in MQTT because, yeah, the state might got changed from another process. So let's say our Node-RED flow might want to know about how the state got changed. So the topic is, well, again, that's the default topic that was in the example. So NETIO, the device name, output /1 / state, and the payload is the output /1 / state. And so I think that's probably straightforward. And again, this is not, I mean, the payload itself is not going to change. That's specific to this device. So what is left here is you can also specify the events here, how that or this message is going to be published. And for this particular example, I think for the state of the relay, obviously the only time you want to know about what the state of the relay is if the state changes. So in the events, which is actually an array, you can specify that the type is changed, so that when the value changed, and then the source is, well, it's just basically the source of the change is the same as what's going to be the payload. So this is how you specify that I want to get a state value MQTT message whenever that state changes. I think that's probably easy to understand. So that's how this part of the MQTT flex looks like. Next, let's move over to something which is a slightly bit more complicated. That's going to be the power. So that's the actual wattage that is being drawn by the device which is connected. So here the topic is going to be, I just used /power, and the payload is going to be again output/1/load. Again, I'm just referring back to the documentation where it says what are the different data that can be published. So it's here. And next we need to specify the events as well. And here we are going to use two different type of events. So there is a timer based event which says the type is timer and the period is the number of seconds. That basically says that no matter what happens, every 10 seconds send me what is the current power usage, or the power consumption. And as I said, because the event can accept an array, you can also specify another way this data gets published, which is the type delta. And again, the source is, it's basically, well, the power. So this output/1/load. And then in the delta value, you specify 1. That basically says that if the power consumption, or the wattage, changes by 1 watt, then publish the data. So that is very similar to what we have seen in Tasmota, where you can specify I think it's called a power delta. It's just basically the same. So you can set Tasmota to send a message whenever the power changes, and that's what you are doing here as well. So I'm telling NetIO to send me a power reading or a power MQTT message whenever that power value changes by 1 watt. So that would be the settings for the power. And I can start scrolling down to all the other settings, but they are going to be pretty much the same. So the voltage, again, voltage, the payload is going to be the voltage value. I'm also specifying that it has to be a delta and has to be the timer. So that again, the voltage change is going to be 1. I mean, you can put a higher value if you want to. And I put the timer to 60. So, I mean, I don't care too much about the power. So, even if it doesn't change, just, send me a reading every 60 seconds. So at least I'm getting 1 reading every minute, even if that value doesn't change. And I've done pretty much the same for all the other values. So you can see that's the current reading. So the source is the current. In the delta, I specify 10 because the current is in milliamperes. So I just said, yeah, 10 is fine, and the timer is 60. Power factor is similar. The delta I specified as 0.1 because that comes as a 0 point something as percentage. Frequency is pretty much the same. Oh, why did I put on? I think it should be 1, to be honest. So that's the frequency. Energy is oh, okay. This is like first version. So the frequency and the energy is they are all integer numbers. So we are not getting 0.1 kilowatt. Not getting 0.1 watt hours because the output here is actually watt hours. I think in Tasmota it's kilowatt hours. So just be aware of that. And I've also said that I also want to know about the energy start. So that's basically just a string when the power consumption started. And actually I've only specified that I'm only interested in if there is like a delta change, meaning that if I reset the counter, because that would obviously reset the start value as well, which is fine because otherwise this value would never change. But if I only leave it in delta, that means that unless I reset, it's never going to get changed, so I would never get a message. So we are going to see that I've put together a simple flow where I show all these values, and this value doesn't have any data in it because it doesn't get changed, it never gets sent. So I think I'm going to also include a timer here, like a 300 timer or something like that. Here you go. So I think that looks better. So every 5 minutes I'm just going to get the start, which most probably never going to change. Oh, and one more hint for the documentation itself. So again, in this application note 40, there is, it's pretty much in the top, there is this link which says MQTT flex. And here, if you scroll down and you click here, MQTT flex on NetIO wiki, then you can I mean, I think that's probably the proper documentation. The application note more is an explanation of, and it's going to walk through how it how you set it up. But here is, you see all the details. And for example, here, all the way down here, you can see some of the other special device details. Like in payload, for example, you can have the payload as a device name, or the Wi-Fi signal, or the uptime. And sometimes I'm using this just to get some stats from my device, like, you know, how it's being used, what is the Wi-Fi strength, and that sort of stuff. So I think I'm going to include these as well. So I think that's all that I had to say about the MQTT Flex configuration. And actually, besides MQTT, there is also another functionality that we could use, but I think this video is going to be long enough, so I'm just going to mention it. I'm not going to test it out, but besides sending MQTT messages, you can also create an HTTP post request, which you can easily handle in Node-RED. So you can enable this NETIO push, and you specify the IP, or sorry, the URL, and then the push period, or so that would be the same, you know, the timer functionality and the data functionality. So, for example, with these settings, there would be a push message every minute, or if the current changes 1 amp. And the protocol is going to be JSON. So you will be getting in a post request a JSON string which contains all the power consumption and state and all the data that we have seen in MQTT so far. So, but let's just not enable that. Just stick with MQTT. Let's have a look what I have done in Node-RED in order to control and also receive the data from this device. And this is a rather complicated sheet, because I will be talking about stuff about logging consumption and then doing statistics on consumption, and these are the same flows that I've used in the past. So if you are a regular channel viewer, you probably have seen the video about these. So here I'm just going to briefly mention about them and how I customize it for this specific device. But if you want to get the details about how these work, I'm just going to leave a link in the cards for that video. So let's start with the basics. So the control, that's my first tab. And as you can see, basically we have 3 different modes. So you have the on-off switch, so you can turn the device on. Probably you can hear the fan going in the background. You can turn it off, and as you can see, we are also listening to the status message, so this changes between on and off. You also have a toggle, so again it comes on, or the toggle takes it off. I haven't implemented this being changed whenever you use some of the other ones, but you could do that. And also you have the momentary function when it comes on for 2 seconds. That was it. So the way we use the delta in the MQTT Flex configuration, it appears that, you know, we are getting data constantly, but in fact we are only getting the data when it's being changed. So it gives an illusion that there is like a, you know, complete feedback loop. So as you can see, as I turn it on, of course the current goes up. We have the power. Oh, this should read watts, not milliwatts. And yeah, power factor, the frequency, well, the frequency doesn't, but the power factor changes as well. And we can see the time and the date since the consumption calculation started. And actually, let's look at how these work. So actually rather simple. So if I go to the top of the flow, now you can see, let me do this one, that so these are the basic controls. So I've created some examples how you do the on-off, the momentary, and the toggle, and basically you're just sending out a string, and the values would be 0, 1, 3, and 4. I haven't implemented 2 and 5 because I think these will be the ones that get used the most. And of course you can do the same with switches and buttons as well. And the data which is coming back is very simple. Again, MQTT in nodes which subscribe to the various topics. So this is the state which shows whether the relay is on and off, and then you have all the power data. And as you probably have noticed in previous examples as well, if you are sending values like numerical values over MQTT, when it comes over to Node-RED, it is always treated as a string. And in most cases, I don't care because it's only getting displayed. So I'm not really worried about the fact that it's string and not a, not a value. But for example, in the power factor, the value comes as 0.61 for 61% power factor. So I want to convert it to percentage, and so here I've just added a function node which converts the message payload to number and then times it by 100. So we see the the percentage value for example here power factor is 100%. So these are the simplest part of the flow. The next one is this consumption logging. Is a piece of it's a little bit of math, which what it does is it receives readings and then it aggregates the readings within these aggregation periods. So at the moment it's set to 15 seconds, which means that it waits for all the readings for 15 seconds, and within that period it calculates the minimum, the maximum, and the average values. As I mentioned previously in my videos, I think these are particularly useful when you want to make sure that you trigger on something which is not like a abnormally high value, but more like an average, which in most cases probably better represents how your device is working. And we have the various outputs. So you have the minimum, the maximum, and the average output here. And actually I'm doing something with the average, which I'm going to talk about a little bit later. And all I'm feeding into this flow is the power reading. And the only change or the only modification I've done to this flow here, which is it's here. So I just modify the code in here where it gets the power. With this NETIO device, the power value comes in a message payload, but as I said, it's text, so I'm just using parsing to convert it to a number. And then the rest of the flow just works as in most of my examples. So I don't have a really good data at the moment because it's only created to a fan, but I think after I finish this video, I'm just going to move it over to a device which continuously uses power, so we have like a nicer curves that just shows the functionality if you haven't seen it in the previous video. I was using this consumption logging just to better understand how my device is working, and then sort of like fine-tune my logic, which acted upon certain changes in devices. So again, one of my previous example was that I had a power monitoring device connected to my washing machine, and I was able to set up a trigger which tells me when the washing has completed based on how the consumption goes up and down in a particular cycle. And a separate piece of calculation is these power statistics, in which I'm taking the power value, which is, well, it's 1 watt-hour at the moment, and every hour, every day, and every week I calculate the delta. So this consumption becomes like an ever-growing number until you reset it, but let's say you don't reset it normally. So what I'm using is every time and every hour, every day, and every week I take a snapshot of what the value was, and then the next hour, the next day, the next week I do a snapshot again and I calculate the difference and that gets plotted in a graph as well. So we don't see a lot of data at the moment because this is a fairly new device. So I'm just going to go back to one of my other examples where I have this one connected to. Actually, this is an old device as well. Yeah, I don't have my other test device connected to my fridge, but I have one of my other one connected to the washing machine. So you can see that we just finished the washing. So between 6 and 7 p.m. there was a 0.7 kilowatt hours usage, and yeah, today we used 0.8. But if you look at the number of days going back, the last time we used the washing machine was the Thursday the 28th, which was again 0.7 kilowatt hours. So probably that was one wash as well. And the weekly at the moment is empty because again, it's fairly new devices, fairly new flow, but that's how it works in a nutshell. Again, more details on that in the other video. And make all this calculation work, I've taken the energy topic from NETIO and I've just fed it into this power metering function, and in here I've modified the flow in these two lines, which basically says that if the topic includes the energy, so that's specific to this message, then I know that I'm receiving a new energy reading or consumption reading. And again, because it comes through as a string in the message payload, I'm just converting it to a number using the parse int. And the rest of the code is, oh, sorry, not the rest of the code is unchanged. The other thing that I've modified from my other example from which I copied this one is I specified the global variable which is getting used, and yeah, you can make changes in here as well, how many hours, days and weeks it will keep the history. And that's pretty much it. And of course there are a few tweaks here in this is one of my example how I store the data in the SQL database. Again, that's only applicable if you would be using the same SQL database as me, but at least you can use this code to see how I'm getting the data and how I'm storing that one. Also, I do the same for the daily and the weekly consumption. And I have this habit of always saving any charts. So if the Node-RED restarts, then at least it doesn't need to load the chart. You know, the chart doesn't start from the beginning. And this is what I've done. So every time the chart updates, it gets dumped into a file. And then if the Node-RED restarts, it basically just reads the same file over. So if you are reusing this flow, just make sure that you revisit these file names and you provide a path which actually exists, or just provide a path where you want to save these files if you want this functionality at all. But that's all about the power monitoring and generating all the statistics. And next, let's talk about the automation. And again, I'm referring back to the previous video that I did on power management and using power data in Node-RED, because I'm using exactly the same examples here that I talked over there. Obviously, I just modify the flow to work with the NETIO device, which is pretty simple because, again, all we need is the MQTT topic where the energy comes in. We need to convert it to a number. So I'm just doing this JSON conversion, like the $ number and message payload. So this converts it to a number. And the free use case I come up with is that based on the output of the statistical flow, I can make decisions whether, for example, I want to turn off my device if the hourly consumption exceeds 1 kilowatt hour, or the daily consumption exceeds 1 kilowatt hour, or let's say the last 24 hours exceeds 1 kilowatt hour. The difference between daily and the last 24 hours, because obviously the daily gets reset at 0 hours, 0 minutes. So if your device is running during daytime, it doesn't make a difference. If it's sort of like running 24/7, then you might want to use the later. And all I'm doing here is I'm checking the value of these global variable that my flow has created. So power_NetIO is the global variable that I've defined here. So this hour property or attribute gives me the usage this hour, and the daily is going to give me the total for today. And this one just sums up the hourlies for the last 24 hours. And that's pretty much it. And that actually reminds me that I have to make a small change here. And actually this reminds me that I need to do one more small change here in this flow, because this flow, I've done it originally when I was using my Blitzwolf meters and Tasmota, which is giving the consumption in kilowatt hours, but NETIO uses watt hours. But I think probably kilowatt hours is what is a better metric to use, because, well, unless you have some really low power devices where the kilowatt hour reading is going to be so small. So anyway, I think what I'm going to do here is I'm just going to divide whatever value I'm getting by 1,000, so I'm getting the kilowatt hour readings, because not that it makes a huge difference, but for example the text on the screen and all these figures are on kilowatt hours. So I think the value should be, well, at least the value should reflect that. And that also remains that I should have changed that one to watt instead of milliwatt. I was just probably doing a copy and paste of the current, which is milliamps, and now, you know, it should be watts. And that should be it. Oh, sorry, I haven't finished. So so that was all about consumption. The other thing I did is when you want to make an automation based on the actual power reading. And again, you can use the power reading, which comes off from here. So that would always give you the actual power. And again, this, you just have to understand that this is all based on sampling. So I don't know, for example, the device probably can take a power reading every second. It is only going to show you what the consumption was in that exact second when the measurement was taken. And I've taken it one more notch down, because I said I already have this flow here which aggregates the, you know, the readings in let's say in every 15 seconds. So I think I should be really using the average of these outputs. So I have an in a link node here which goes in there, and basically I'm saying this: if this is beyond 25, so if my 15-second average consumption is above 25 watts, I want to turn off the device. And then, by the way, these also turn off the device. So all I'm doing is I created this change node which changes the payload to 0, and that's the off signal. And I'm sending this off to the action MQTT topic. So NETIO, the device name, output /1/action. So that's where you send the 0, 1, 3 and 4s, and also 2s and 5s as well. And the third thing that I thought you might want to do a trigger on or automation on if your device is running for a certain amount of time. So what I've done here is I've taken the state topic, which gives me 0 or 1 based on whether the device got turned on or off. And whenever it's getting a 1, it starts counting. So for example, if I turn this on, as you can see, it starts counting. And by the way, this is going to turn it off in a very short amount of time. So now it's counting, and it will just keep counting as long as the device is on. And in the output, it will send a message which is going to be the number of seconds. So it sends 18, 19. So it sends a message out every second. And here I'm just doing a very simple, again, a switch node which says if the payload is greater than 3600, which is 1 hour in minutes, so in seconds, then again turns the device off. And the reason I have this example, because let's say you have a space heater connected to this device, and you know that even if the house is really, really cold, it is probably switching on and off every 10 minutes or 15 minutes or something like that. So if it's running for an hour or more than an hour, maybe that's a sign that the temperature sensor has gone wrong and it just stuck open or stuck closed, and you know, it's not doing the usual on-off cycle. Something like that. But I think this could be useful in a few scenarios. That was my fairly long video of the NETIO network power sockets. I hope you found this information useful. Thanks for watching, and hopefully see you in the next video.